Hi, welcome to the demo recording of OpenStack deployment using RDO-Manager. My name is Jaromir. I work at Red Hat, and I'm project manager of RDO, which is the Red Hat's distribution of OpenStack, and I'm mainly focusing on RDO-Manager. At this recording, I'm going to give you a walkthrough of basic deployment of OpenStack using RDO-Manager. RDO-Manager is a community project which is not just deploying but also managing RDO. This project is based on OpenStack 000, which is an upstream of official deployment program, and its philosophy is inspired by Spinal Stack project from Innovance company. If you go to the RDO-Manager website, you can find information about RDO-Manager itself. There is architecture information, list of components, URL for repositories, and you can definitely go to the documentation and try the RDO by yourself. You can also find various presentations which we are recording in time. So let's go to the documentation and follow the flow there. This is the RDO-Manager documentation. In these sites, you can find information about the project, about environments where the RDO can be deployed, how to install the Undercloud, which is a small restricted OpenStack cloud used for deploying and managing your OpenStack. Then basic deployment, which is a set of steps of how to easily deploy your OpenStack. Advanced deployment, which obviously contains advanced steps during your deployment. Troubleshooting, if you find yourself in troubles. And last but not least, section of how to contribute. You can contribute by code, but you can also report bugs or request features. So let's start and move forward. Before we start, we go to the menu, and since this documentation is covering multiple environments, we choose the environment-specific content which we want to see in the documentation. RDO-Manager can be used on top of CentOS or RHEL. For purposes of this demo, let's choose CentOS. If you have chosen RHEL, you would need to register your system, but since we chose CentOS, we don't need that. RDO-Manager can be deployed in bare metal environment as well as virtual environment. For purposes of this demo, to make it easier, let's deploy into the virtual environment. You can also use Ceph as a backend for your storage. Let's not do that at this moment. Once we limited the content, let's go to follow the documentation. First step is to set up our environment. We chose virtual environment. For virtual environment, you need to at least one actual bare metal where you will be setting up your virtual machines. On this bare metal, you need to have at least 3 virtual machines: one Undercloud, one Overcloud controller, and one Overcloud compute. Those virtual machines need to consist of at least 4 gigs of RAM and 40 gigs of disk space. These virtual machines will be auto-created with the script below. Let's move forward and prepare the virtual environment. First step is to install CentOS on your host machine. I already did that, so I'll just log into my machine. And check what type of distribution I have there. So I have CentOS release 7.1. Make sure that your SSHD service is installed and running. You can see that it is running on my machine. Then you need to create non-root user for the security purposes. So let's go forward and let's create a user. I create a user, I specify a password, and I give him needed privileges. Once I have the user, I go and log as that user. Once the user is created and I'm logged in, I need to enable repositories. For virtual environment creation, I need to enable extra packages, RDO, Kilo, and RDO-Manager trunk repositories. All of them are listed in these 3 simple steps. Once we have it done, we install Instack Undercloud, which is a project which will create the virtual environment for us. Once we finished, we go to the actual virtual environment setup and we run command instack virt setup, which will create a virtual environment for us. Once the script has finished, you have your virtual environment ready for use. Let's check it out. You can see that I have 3 virtual machines. One is called Instack, which is the virtual machine which will be dedicated for my Undercloud, the deployment cloud. The other 2 machines, named bare metal with number, are virtual machines where I will be deploying my actual OpenStack cloud. So let's log into the Instack machine, into the Undercloud. We will follow with installing the Undercloud chapter. So we have logged into the Undercloud machine. The script creates non-root user for you, so you don't have to follow the steps for creating the user. If you don't have that user available, you can follow these steps. Let's log as the non-root user, and let's keep going. Now we need to enable repositories which are having the packages which we need. We are enabling RDO Kilo repository and RDO-Manager trunk repositories. Both are based on Kilo version of OpenStack. Now we go to install the CLI tool. And once it is done, we go and simply use OpenStack Undercloud install command, which will install the Undercloud for us. Under the covers, there is running Instack Undercloud script, which is using Puppet modules to install the small restricted OpenStack version, which will be deploying and managing your OpenStack cloud. Alright, perfect. Now we have installed Undercloud and we can move forward to start preparing our Overcloud, the actual OpenStack tenant-facing cloud, and deploy it. To make it more convenient, there are passwords created in the root home directory. So let's just copy them to the non-root user home directory to make them better available. Now let's go to the documentation, root page, and follow with basic deployment flow. We already have our environment prepared and installed the Undercloud. We are logged in the Undercloud machine as non-root user, so we just source the stack.rc file, which contains the passwords as I mentioned before. Once the passwords are loaded to the environment variables, let's go forward. First step is creating images. These images are Overcloud images. These images will be provisioned on your actual nodes. They are having full set of OpenStack services, so we are using actually one generic image. To build the images, there is a simple command called Instack build images, which will create Overcloud full images, which are images containing all the OpenStack services. There is RAM disk and kernel disk. Then deploy RAM disk images, which are used for PXE booting when you are deploying your nodes, and discover RAM disk images, which are used for hardware introspection. There is also one special image, the testing image, used for testing your deployed Overcloud. Excellent. Now we can see that we successfully built all the necessary images. Let's have a look if it actually really happened there. I see deploy RAM disk, I see discover RAM disk, Overcloud full images. Looks that everything is on its place. We go forward and we upload images to Glance with this one simple command. Let's have a look if the images are actually in the Glance. I see I have deploy RAM disk, kernel disk, Overcloud full image with their RAM and kernel disk there. So once we have images, we need to go forward and register nodes. For registering nodes with Ironic, we use one simple command which takes JSON file which contains mainly IPMI or PXE SSH credentials, so Ironic can PXE boot the node, which are the necessary required information what you need in order to register the node successfully. Let's just have a look on how the Instack and the file looks like. I have PM address, I have PM password, which is a private SSH key. The power management type is PXE SSH, MAC address. I also have information about CPU, memory, disk, architecture, but they are not needed because they can be very easily auto-discovered. So let's upload the file and register the nodes. Alright, I can see that Ironic created two nodes for me. One and second one. We go forward and we introspect hardware for their attributes. What is happening in the background is that we are PXE booting the nodes, we are deploying the RAM disk image and running discovery job there. We are introspecting for hardware attributes, and we are also running basic benchmark tests in order to make sure that the hardware is performing correctly. The whole process takes about 2 up to 5 minutes in the virtual environment. It can take up to 15 minutes for bare metal. Alright, introspection has finished. Let's just check if the information were added into the nodes. Ironic node list, show, and we will show one of the nodes which we have available. Alright, ironic node show, not node list. You can see that there is a bunch of information added. It's not very nice formatted because I have large screen. But there's information from benchmarking. And you can use them to advanced filtering when you are selecting which node will be deployed as controller or compute. Okay, we have hardware ready, so let's move forward and create flavors. Flavors are used as node profiles, which will be then used as the condition on what type of node you are going to deploy your roles. So controller, compute, or storage roles. In this example, we are with one script creating one simple flavor called bare metal, which is generic flavor covering all hardware I have. I don't care at this moment if my controller goes to the first node or the second node. The same goes for compute because I have very same specification for both. So I need just one generic flavor. So the flavor is created for me. Last step is just the actual deployment. What happens now is that we are triggering a script which will create and define Overcloud roles for me. It is defining controller role and compute roles. It is associating images with it, which we created in the steps before. The same goes for associating flavors, or actually one flavor which we created before. It is entering one count of each, so we are deploying one controller and one compute, and we are calling Tuskar commands to make all of that happen. Once we have that done, Tuskar will generate Heat template file, which will be served into Heat. Heat will consume this file, and it will orchestrate the deployment for us. The deployment consists of searching for the right nodes which are matching the node profile, the flavor which you associated with the role. Once the node is targeted, it is provisioned with the image which was associated with the role. And once the image is provisioned, we are running Puppet runs in multiple steps, actually 5 steps. And after each step, we are performing basic tests, making sure that the services are up and running. Excellent! We have successfully deployed Overcloud. To make sure that the Overcloud is actually working, let's trigger a very simple test, which will spin up the virtual machine in the Overcloud and try to ping it to make sure that it's reachable. All the tests passed, and now we are successfully done having very simple OpenStack cloud deployed using RDO-Manager. Thank you for your attention. If you have any questions, just follow the RDO-Manager website, which will point you to the right places.